Okay, so I was talking about the lamp efficiency. Okay. So it is the ratio of lumens emitted by the source divided by the wattage of source of light. Okay, that is the output is the lumens which is emitting from the source, and what is the input? It is the wattage of the source of light. ठीक है, किसी बल्ब का रेटिंग क्या है? अगर वो 100 वॉट का है या कोई एलईडी है 15 वॉट का है, 14 वॉट का है, ठीक है, so that is the wattage of the source. So it is the ratio of the lumens emitted by the source divided by the wattage of the source of the light. That is lamp efficiency. Okay, the next term is the space height ratio. What is this space height ratio? नाम से तो सिंपल पता चल रहा है कि it is a ratio between the two distance. Okay, ये distance क्या है? It is defined as the ratio of horizontal distance between two adjacent lamps and height of the lamp from the working plane. Distance between two adjacent lamps divided by the height of the lamp from the working plane. This is the space height ratio. ठीक है, इसको समझ सकते हो एग्जांपल से बेटर वे में. सपोज एक रूम है, ठीक है, अपना क्लासरूम ही समझ लो. ठीक है, अपना क्लासरूम है, बेंचेस लगे हुए हैं, ऊपर में दो ट्यूबलाइट्स लगे हुए हैं, ठीक है, उस रूम में. तो वो जो दो ट्यूबलाइट्स है दोनों सेम प्लेन में है, एक ही प्लेन में है. ठीक है, ऊपर रूफ टॉप से सेम हाइट पर है दोनों. तो वो दोनों हो गए टू एडजेसेंट लैंप्स. ओके, ठीक है, दोनों लाइट सोर्स, दोनों ट्यूब. तो उन दोनों ट्यूब के बीच में जो डिस्टेंस होगा, हॉरिजॉन्टल डिस्टेंस. ओके, सो इट इज द रेशियो ऑफ हॉरिजॉन्टल डिस्टेंस बिटवीन टू एडजेसेंट लैंप. उन दोनों ट्यूबलाइट के बीच में जो डिस्टेंस होगा, दैट डिस्टेंस डिवाइडेड बाय the height of the lamp from the working plane. What is this working plane? Working plane जहां पे हम लोग कुछ वर्क कर रहे हैं. ठीक है, बेंच. तो क्लासरूम में बेंच रखे हुए, वहां पर बैठ करके अगर लिख रहे हो, so you can consider that as the working plane where we have to work. Okay, so what is the height of that tube light from that bench? That vertical height. Okay, you can consider that height as the height of the lamp from the working plane. Okay, so it is the ratio of the distance, horizontal distance between the two tube lights and the vertical distance between the bench and the tube light. Okay, so in this way you can calculate this space height ratio. Clear? The next one is the depreciation factor. Okay. Depreciation factor is the ratio of illumination when everything is clear divided by the illumination under normal working condition. Okay, illumination when everything is clear divided by the illumination under normal working condition. कहने का क्या मतलब हुआ कि अगर एटमॉस्फेयर बिल्कुल ही क्लियर है, ठीक है, फॉगी, सपोज फॉगी वेदर नहीं है, विंटर सीजन में वेदर फॉगी नहीं है, बिल्कुल ही क्लियर है, तो उस वक्त इल्यूमिनेशन क्या होगा किसी लाइट सोर्स का? illumination when everything is clear. Okay, and the illumination under the normal working condition. Under normal working condition winter season में थोड़ा बहुत फॉग रहेगा, ठीक है, उस वक्त illumination क्या है? That means it is the ratio of the illumination under two different conditions. You can understand in this way. Okay, under two different situations, what is the illumination of a particular light source? That is defined by the depreciation factor. Okay, ये दो different situation क्या क्या है? एक standard situation है, when everything is clear, it is the standard situation, and the second is the normal situation, normal working condition. ठीक है, तो ये तो कह सकते हैं कि under standard situation, when everything is clear, the illumination will be at highest level, and under normal working condition, illumination will be little bit lower than the standard level. Okay, so this ratio will be greater than 1 always. Okay, so the depreciation factor is always greater than 1. Okay, am I clear? Yes sir.
Yes, sir.
Okay, so समझ गए स्पेस हाइट रेशियो क्या है, डिप्रेशिएशन फैक्टर क्या है. अब आता है नेक्स्ट मेंटेनेंस फैक्टर. अगर डिप्रेशिएशन फैक्टर निकाल सकते हैं तो इट इज द रिवर्स ऑफ द डिप्रेशिएशन फैक्टर. ठीक है, 1 upon depreciation factor that you can calculate for the maintenance factor. So if depreciation factor is greater than 1, so maintenance factor will be less than 1. Okay, next one है हमारा specific consumption. It is the ratio of the power input to the source of light to its illumination intensity. Specific energy consumption पढ़े थे ना, and like that, it is similar to that. It is the ratio of the power input to the source of light. Okay, कितना input power हम लोग दे रहे हैं divided by its illumination intensity. Okay, power input का unit क्या होगा, watt, and unit of this luminous intensity is candela, so it is watt per candela. It is a specific consumption. Last three terms है absorption factor, coefficient of utilization, and waste light factor. Yeah, ये तीन terms है. I think time is over, but I will take 5 more minutes, okay, to complete these three terms. Then the basic terms related with the illumination will be over. Okay. So, what is this absorption factor? So, in case of the factory or a place where the atmosphere is full of smoke or fumes, okay, so it is not the clear atmosphere. Okay, there is possibility of absorption of light energy. Agree with this statement? अगर एटमॉस्फेयर में कुछ स्मोक हो, ठीक है, that is we're not able to clearly see the things around you. Okay, then if you switch on a light source, okay, then you will not be able to see a particular object clearly when the atmosphere will be cleared, if you compare with that situation. Okay, that means there is some absorption of the light or the distraction, whatever you can say. That means the light intensity is not falling upon the object. Okay, so this absorption factor is defined as the ratio of the net lumens which is available after absorption of the light. Okay, so whatever lumens reaching to this particular object through that atmosphere, okay, that is talking about that net lumens. Okay, that net lumens available after absorption of the light. divided by the total lumens emitted by source of light. Okay. Suppose if a source of light is emitting 100 lumens, and when it will reach to the particular object, only 80 lumens is reaching to that particular object. So this absorption factor is 80 divided by 100. That is 0.8. So this absorption factor is 0.8. Clear? What is the meaning of this absorption factor?
हेलो
हेलो। अथी कर लिए जो अथी वाला आया था।
कहाँ की आज लास्ट डेट है?
हाँ कर रहा था, ज्वाइन करना है कि सबको?
हम 6 दिन है हमको।
Next one is coefficient of utilization. Okay. Coefficient of utilization is the ratio of the lumen reaching on working plane divided by total lumens emitted by source of light. ठीक है? It is very much similar to the absorption factor. वही दूसरा एग्जांपल फिर से ले लो, वही जो क्लासरूम का था। क्लासरूम में जो ट्यूबलाइट्स अगर लगे हुए हैं, ठीक है, तो वर्किंग प्लेन जो हमारा बेंच है जहां पर लिख रहे हो, उस वर्किंग प्लेन तक कितने ल्यूमेंस पहुंच रहे हैं, ठीक है, कितना लाइट वहां पर पहुंच रहा है उस बेंच तक। So the lumens which is reaching to that working plane divided by the total lumens which is emitting from the tube light. Okay, so the ratio of these two lumens is called the coefficient of utilization. Okay, so basically it is talking about how much we are utilizing, and this absorption factor is talking about how much it is absorbed to the atmosphere. Okay, that is the basic difference between this absorption factor and coefficient of utilization. And the last one is the waste light factor. वेस्ट लाइट फैक्टर को समझ सकते हो एक एग्जांपल के थ्रू। सपोज कोई स्टेडियम है, ठीक है, स्टेडियम में फ्लड लाइट्स लगे हुए हैं बहुत सारे। किसी एक पर्टिकुलर फ्लड लाइट में इस तरह के बहुत सारे एलईडी कहो या फिर बल्ब्स रहते हैं, ठीक है। ये एक पर्टिकुलर फ्लड लाइट है, इसके अंदर बहुत सारे डिफरेंट एलईडी रहते हैं, ठीक है। या अभी भी अगर कोई एलईडी अगर कहीं मार्केट से परचेज करो फ्लड लाइट के लिए, तो उसके अंदर भी देखोगे छोटे छोटे एलईडी बहुत इस तरह से कनेक्टेड होते हैं सीरीज पैनल में, ठीक है। तो जब ये फ्लड लाइट को अगर स्विच ऑन करते हैं, तो यहाँ से जितने भी लाइट एमिट हो रहे हैं इन ऑल डायरेक्शन, but the light which is reaching to the working plane, okay, at the surface, okay, that is after reflection or after absorption, ठीक है। So this waste light factor is related with that term. Okay. See, in flood lighting system, a number of projector lamps are employed so that light of each projector not only overlap that of its adjacent projector, but at the edges of the area, some light fall outside. ये जो light जो small lamps है, इसके corners पर यहाँ से जो light emit हो रहा है, that will be absorbed by the surrounding areas. Okay, ये जो इसके metallic parts है वहां से वो स्ट्राइक करेगा और फिर वहां से एब्जॉर्ब हो जाएगा, वेस्ट हो जाएगा, ठीक है। वो लाइट हमारे वर्किंग प्लेन तक नहीं पहुंचेगा, ठीक है। सो देयर इज सम वेस्टेज ऑफ द लाइट intensity, okay, which is situated at the corner side of this flood light, So in order to compute total lumens which is required, theoretical lumens required are multiplied by this wave light factor. So working plane तक कितने lumens required है, so that we can clearly see the object. Okay. अगर हमारा टारगेट है कि वर्किंग प्लेन में 100 lumens पहुंचना चाहिए और बेस्ट लाइट फैक्टर अगर सपोज हमारा 10% है या 15% है, तो हम लोगों को ये फ्लड लाइट जो सेलेक्ट करना होगा, हम लोगों को देखना होगा कि वो इस वेस्ट हमारे वर्किंग प्लेन पहुंचेगा, ठीक है। बाकी में होगा that be a wastage absorbed in the waste light to multiply the lumen by the waste, what should be the of a light source.